The threshold wavelength of tungsten is 2300 angstroms. If ultraviolet light of wavelength 1800 angstroms is incident on it, then the maximum kinetic energy of photoelectrons is to be calculated. So the work function of tungsten is given by hc by lambda t, where lambda t is a threshold wavelength, h is the Planck's constant, and c is the speed of light in vacuum. And now the energy of photon is given by hc by lambda, where lambda is the wavelength of the photon. The kinetic energy of a photoelectron would be equal to the amount of energy that the photon is carrying, hc by lambda, minus the amount of energy required to separate the electron from nuclear attraction, which is hc by lambda threshold. So we have Planck's constant is 6.6 into 10 to the power minus 34 in SI units. Speed of light is 3 into 10 to the power of 8. We have 10 to the power 10 divided by 1800 minus 10 to the power 10 divided by 2300, and this would give us an answer in SI units, which is joules. If we divide this by the charge on an electron, that is 1.6 into 10 to the power minus 19, then we would get the energy in terms of electron volts. And if we complete this calculation, we find that it is equal to 1.49 electron volts. And hence option A is the answer.